Recording. Welcome everyone to React Chicago. Bill, you'll have to refresh my memory. I think I spoke at React Chicago a long time ago, maybe 4 or 5 years ago. I don't know if you know, talking about MobX. So if any of you were part of the group long ago, I think that I may sound familiar. So to those of you who don't know me, hi, my name is Art. I'm the CEO of Secure Web Solutions, which is a consulting company that I run out of my house up here in McHenry, which is about an hour north of Chicago. I have been building websites of one flavor or another since roughly 1997, when I was hooked on things like Yahoo GeoCities, which probably shows my age a little bit here. But the web has changed a long time, or it has changed a lot in that time. And single page applications specifically didn't really come about until maybe as early as 2005, 2006, 2007, when jQuery and Prototype.js and EXT.js started to become more popular. So that's really the era that I really started to cut my teeth in web application development as I graduated from college around that time. And fast forward to today, I spend most of my time in React or Stencil building web components these days. So love me some web technology, and React is probably my favorite thing to work in these days. So having said that, I'm going to get on my soapbox for a little bit during the presentation today. And if you aren't already paranoid about getting hacked or having an attacker dig into your web application, I will suggest that you should be, because the landscape of what hackers look like and what they're capable of is significantly wider and deeper than it ever has been. I mean, even going back to 2005, 2006, compared to what things are today, it's so much more dangerous to push code into production today than it ever has been. And ultimately, that is just going to get worse. Way back when I got started, nobody talked about cybersecurity. Over the years, people became more and more familiar with things like the OWASP Top 10. So many of you on the call tonight probably have a pretty good understanding of at least a basic cross-site scripting attack, or the basics of how SQL injection work. Fewer of us on the call would be able to really dissect the inner workings of an attack like cross-site request forgery, or many of the other things that do exist in the OWASP Top 10 today. And that's not a judgment of you specifically or developers at large. It's really just highlighting the fact that there are simply too many attack vectors for any one of us to really understand. And as a result, I suggest that we as developers really need to start looking at the offensive side of cybersecurity so that we can better protect our applications. So today's presentation is going to focus on a couple of things. First and foremost, I am going to go over what I'm going to call the low-hanging fruit, the things that hackers really look for, specifically in the context of a single-page application written in React. I'm going to dive into some very specific React advice, although I'll point out a lot of the advice I'm going to give is equally applicable to other frameworks. So if you're not a React fanboy, if you're in the Angular or the Vue world, or if you're building things natively with web components, a lot of this advice is going to translate pretty well. I like to use a lot of memes and humor in my presentation, so buckle up for some of that. And we'll have plenty of time for Q&A along the way. Certainly, if you have questions, I think Bill said he'll be monitoring the chat, so feel free to drop things in and we can pepper some questions in along the way, especially if it helps to clarify anything that I'm saying. Just to be like extra clear, the presentation tonight is not, a presentation about do this instead of this. There will be a little bit of that, but the larger purpose of the talk, as I said, is to give you an offensive security mindset. If you think about what an attacker is trying to do when they look at any web application, let alone your web application, they're trying to put puzzle pieces together. And sometimes the pieces fit, sometimes like in the image here on the screen, they fit, but they don't really tell the correct picture, or sometimes it's hard to get a clear picture of what an attacker is trying to do. The point being that the more puzzle pieces you give an attacker, the more successful they're going to be at attacking your application. And we want to avoid giving them all those puzzle pieces. So if you'd like to follow along with the two examples I'm really going to dive into tonight, feel free. I'm going to talk through each of these two examples in detail here. And the first example is a website called cyberscavengerhunt.com. And this is a site that I created about 2 years ago, or at least I came up with the idea as I was finishing a penetration test for one of my clients. And while we aren't going to go really deep into hacker theory tonight, it's important to understand that the hackers are looking for that low-hanging fruit. The more low-hanging fruit they find, the longer and harder they're going to spend their time trying to break into your app. And the less of that low-hanging fruit they find, the greater the chance they're just going to move on to an easier target. Now that's true, or more true in some cases and less true in others. I mean, if you're working for a multinational bank or a government institution, you can probably guess you're going to have stronger adversaries than if you're just building a simple app that you want to show your friends. So take some of this advice with a grain of salt, but we're going to dive right into this first example that I call the cyber scavenger hunt. And as I mentioned just a second ago, attackers are constantly looking for these puzzle pieces. Their first move is always to do some form of reconnaissance or enumeration of your web application. And one of the things that an attacker is always going to do is to think about the things you don't want them to see. And one of the easiest ways to think about that is perhaps what are the things you don't want Google to see? If you're building a website, a web application of really any kind, most of you are probably familiar with where these hints are going to lead us here. And so developers are really good about putting up signs to say, hey, Google, don't go look at this thing. If you know what that thing is, then an attacker is immediately going to go to look at that. And the robots.txt file is that first place an attacker is going to look. And yes, we have found the first of the 8 Easter eggs that exist on the cyber scavenger hunt. So while it's really good practice from a search engine marketing perspective to make sure that Google's not indexing sites it shouldn't be, this is obviously going to give an attacker the idea that, hey, there's some page I might not have been aware of. Let's immediately go and check out what that is. So I can come in here and just type in /admin, at which point it brings us to the second of the Easter eggs here in the cyber scavenger hunt. And before we go any further, yes, this is a highly contrived example, but stay with me. I promise there are nuggets of wisdom along the way. So in this case, there's an admin page that an attacker wouldn't have known about if it weren't for what was in the robots.txt file. So one of the important things here is that when an attacker finds a page they weren't supposed to find, they're going to continue doing their enumeration. This is a circular thought process where every time they find something new, they try to reapply all of that enumeration logic until they find all of the things they possibly can. So what are some of those other things? Well, in this case, the hints are leading us to something about browser dev tools. And if we pop open our JavaScript console, we'll see some comments that the developer of this site left in to help them debug something. We also found the third of our 8 Easter eggs. So moral of the story here, be careful with your console logs or things that you might put out for debugging purposes when they're on a production application. Because in this case, you may not have even noticed that I had a URL parameter of authenticated up at the top. Well, if we change that to true, again, with a highly contrived example, we'll see that we have bypassed authentication in this app entirely, which is bad. But to my comment a moment ago, they're going to continue enumerating. So they're going to find other links to pages that we didn't know about. And we'll follow that link and find yet another hidden page, something that wasn't noted in the robots.txt file. As a side note, if you're enjoying the scavenger hunt and you want to sign up for my email list, please fill out the form below. Again, so we're on this hidden page with the highly contrived authentication example, but let's look for our next set of hints here. Perhaps numbers like 200, 301, 404, and 500 mean something to you. And as a web developer building React apps, I suspect they do. Hint number 2 is more explanatory. There's lots of data in this next Easter egg, if you can find it, that's not part of the message body that gets returned from either an API request or just a web server in general. And specifically, I'm looking for things in the header. So if we go over to our network tab and we pull open maybe the index HTML, there's going to be a lot of information in here. Something like, let me bump up the font size here if this is hard to read. Things like Amazon S3 just automatically tells you, as the consumer of my website, that I'm using Amazon. So thank you, Amazon, for just giving that information away. And it's giving all kinds of other stuff away too, like the fact I'm using CloudFront. Maybe there are some other relevant, like AWS code build. So you've got a pretty good idea of what my development infrastructure and architecture is for this application, and you didn't have to look very hard. So be careful turning on or sticking with the defaults for however you are hosting some of your static assets on whatever web server you choose to use. The relevant bit to the scavenger hunt is perhaps my Easter egg header, which tells us to go look further into dev tools, specifically in local storage, to see if we can't find anything else. So if you're familiar with Chrome DevTools, you can go to the Application tab. And I want to look in local storage where we find egg number 7, where we'll learn local storage is one of a number of places a developer might choose to store application data. And all of you are probably like me, and this is 100% true. You might be storing a JWT, or you might be storing different data about either a user or part of the application that you don't want to have to re-request every time from the server. Problem there is that local data is incredibly easy for a malicious user to edit, and that data gets ingested into your application. And because it's local, we tend to trust it more so than we would if it were just vanilla user input, like in some sort of input box. So we're down to one final Easter egg, and we're being told to look in the cookies of DevTools, and specifically at a session cookie. So session storage, I want the cookies, session storage. And this is probably the most difficult part of the scavenger hunt here. If you're unfamiliar with what you see down here in the value box, this is what appears to be a base 64 encoded string. And if you weren't entirely sure why I might jump to that conclusion, other than the fact I wrote this, the equal sign at the end, in my mind, typically gives that away. So I might copy this value, and we can go to a site like base64decode.org, and you can paste that in and decode it, and we find our eighth and final Easter egg of the scavenger hunt. Which, by the way, if you want to go check out something else cool, go check out that link at the bottom. But the moral of this story here is that any encoded data or hashed data isn't always secure. You know, base 64 is a obviously reversible encoding. So if you're going to encode something in base 64, don't expect that somebody can't decode it. And if you're doing a true hashing algorithm, you want to make sure that it's actually a secure hash, one that hasn't been cracked or isn't vulnerable to various attacks. So you know, some of the older MD hashes are no longer considered secure. So just be careful that as you're exposing things in the application, that they are in fact appropriately secured and not just scrambled in a way that could be undone. Again, this is a contrived example because a session cookie typically won't be base 64 encoded, but stranger things have happened. All right, so that's the cyber scavenger hunt. And just to kind of recap, the reason these 8 things are important is because each one of these 8 things is something that, as a penetration tester and a secure aware software developer, I know are places that are frequently unsecured, because on a one-by-one basis, as a developer, we probably feel like, oh, okay, I've got a page in my robots.txt file, but that page is an authenticated page, so I don't really care if somebody sees that. And by itself, that may be a true statement. But to an attacker who's putting together different puzzle pieces, they're going to find that bit of low-hanging fruit. And then they're going to find the next piece of low-hanging fruit. And then they're going to keep looking for things in different places until they start to get a clear picture of what they think could be a threat. And so just be careful doing things like having hidden pages, having JavaScript console logs in a production app. Manipulating query string input is actually a really interesting one. Again, we don't expect users to fool around with those things, and we will probably, in the business logic of an application, just look up window.location.query and pull out a value, and then just go and blindly use that somewhere in the app without actually trying to sanitize its input. Because again, it is untrusted user input, whether or not a user is trying to maliciously change it. All of those 8 things will map roughly into one of these OWASP top 10 buckets. And in some cases, each one of these items might map to more than one item of the OWASP top 10. And again, this is great information in isolation, but most of us are in the business of building web applications. We're not in the business of becoming experts in the OWASP top 10 specifically, or even the things that are outside of the OWASP top 10 that get a lot less attention in the media. It's not possible for us to be experts in all of these things. So what can we do? The answer to that question is to create a threat model of, number one, the architecture of the application. And in my case tonight with the cyber scavenger hunt, I'm including bits of my AWS infrastructure, because that's where my static assets are hosted. And I'm including network requests that go out to, let's say, my marketing database in MailChimp. But I'm going to try to identify where different parts of the OWASP top 10 are specifically relevant to my application's architecture. And just to talk through this for a moment, we can think about the order of operations for how a web browser is going to request the assets for your application. It's going to go, in my case, out to AWS, and that's going to bring a bunch of static assets down to the browser. So in this case, because my assets are stored in Amazon S3, I know there's no dynamic server rendering. So certain aspects of the OWASP top 10 are not going to be relevant in this section of my threat model. Same goes for when I'm looking at the different views of my single page application. There are going to be certain aspects of that application code that are going to map to threats in the OWASP top 10, things like exposing sensitive data that might come from either the static assets themselves or from API requests. Broken access control would mean the example of my admin page, where if I can't control who can get to a page, that's a problem. And that's irrespective of whether or not the APIs that are required on that admin page actually function. I say that because an admin page of any kind, or even if it's not an admin page, just an authenticated page, is going to have links to other assets or other parts of the application that allow an attacker to continue enumerating, even if they can't be successful in making, let's say, authenticated API requests. So you want to make sure we block them from even finding those things. And obviously things like vulnerable third-party code. And then the last part of my threat model involves how the browser is going to store and pull data out of any of its local storage capabilities. Obviously, local storage itself, cookies, session storage, things like that. Because we want to be careful that if a user has the ability to flip a flag saying whether or not they are authenticated or they have some sort of administrator flag, they can just toggle that in local storage, or if they can modify their cookie, that's just going to open up your application to all kinds of threats. So understanding the threat model from a visual perspective and mapping it to those OWASP categories is definitely an exercise that I would recommend if you do. The next thing I want to look at before we get into the React specific bits are just several other ways that, number one, you as a developer can use to find info you might not have thought about your application. But number two, just to kind of prove how easy it is to for an attacker to find out all of the interesting bits about your application just using browser extensions. And so the first example I'll show you is an extension called Wapalizer. And all these Chrome extensions are free, by the way. So Wapalizer will enumerate all of the technologies it can find on the web page and tell you what they are and any correlated version numbers if it can find them. So as an example, it knows I'm using React. It knows I'm using jQuery 3.5.1, which is probably because I'm also using Bootstrap 4.5. It knows that my marketing database exists in MailChimp. It knows that I'm using Google Tags, and it knows that I'm hosting my things on S3. So even if I hadn't gone through all the HTTP headers, if I hadn't looked at all the source code itself, it's really stinking easy to find out this information. Another really awesome Chrome extension, and I'm going to actually visit CNN.com to demonstrate this one, is retire.js. So in a similar vein to Wapalizer, retire.js tries to enumerate all of the JavaScript specifically on your website or web application. And it's going to alert you if there are any known vulnerabilities against any of those JavaScript assets. So as an example, jQuery 1.12 has a number of reported vulnerabilities, and all of these citations will link out to either bug tickets on the jQuery site. In some cases, they may go to GitHub. Let me see here. So that's a jQuery blog. This one goes out to the NIST government website, where it's going to have a lot of detailed information about things like your CVSS score, how the attack unfolds, maybe links to public exploits. So it's kind of scary to think that all an attacker has to do is pull open one Chrome extension, and they'll be 2 clicks away from an active exploit against that bit of JavaScript. So these tools exist, and they're exceedingly easy to use, and they are just getting better and better as time moves forward. Last Chrome extension I really want to highlight is from Shodan. Some of you may be familiar with Shodan. If you're not, it's not exactly a site I'd recommend that you visit on your corporate VPN, because there are some not safe for work things on there. But their Chrome extension does an awesome job of telling you, what's the IP address, the host name, what organization might be hosting the site, what open ports might exist on that server. So this is just a real easy shortcut for an attacker to enumerate all this information. And again, knowing that it's hosted in Amazon isn't by itself a vulnerability, but it's one piece to the puzzle that an attacker is going to look at and say, all right, maybe I found a bit of information over here, found a little bit of information over there. Maybe they found a username or a password, and now they know that I use AWS, and they might think they can go try to log into AWS and compromise my infrastructure. So again, try to give away as little information as you can. Sometimes you can't always control it, but if we can minimize the damage, that's really the biggest takeaway tonight. All right, so now we're finally at the interesting stuff, since we're in a React meetup. What about React? Because I'm sure that many of you have heard the rumor that React.js is really good at mitigating cross-site scripting attacks. And if you've heard that rumor, I'm happy to tell you that rumor is correct. React is probably the best JavaScript framework in terms of its ability to neuter cross-site scripting attacks. Having said that, it is not foolproof. You can't just say that you're using React and say, cross-site scripting is not possible. So let's talk about some of the reasons why that might be. And I've got another website for you. This one's called hackingreact.io. And I'll ask you to be kind if you're going to follow along in your own browser. This site is very much a work in progress, but for the moment, we'll just dig right in here. So as I alluded to, React is really good at neutering cross-site scripting attacks. And the really good example I have here is down here at the bottom is a recreation of what this component will spit out here. So we can see I've got an input box. On change, it's going to call set user input, which is part of my React hook up here. And then it's going to take that value and shove it inside of this div and just render whatever we give it. And we can see that by default, I'm trying to give it an image that has no source, which would throw an error, but then the on error has a bit of JavaScript. So in theory, it would alert an alert box, but it doesn't. So React is doing its job, right? Right. So that's the end of my presentation. Except that's not actually the full story. So we can see a cross-site scripting attack was successful here. And in this case, it's because I chose to use dangerously set inner HTML. And I will suggest that I have yet to see a legitimate reason why anybody has to use this. Although I am confident there are at least 3 of you on the call today who will say, Art, I have a legitimate reason to use this. And I will say, I'm not here to fight you on it. But if you're using it, it's obviously dangerous. That's why they named it dangerously set inner HTML. And if you're unfamiliar with what's happened here, we gave it the same HTML code that we gave it in the prior example, only it didn't render it as a string down here in the box. It tried to literally render HTML code. It failed, and that's why the alert box was able to show. So how do we fix this problem? Well, the easiest approach would be to use something like DOM Purify or any other number of sanitization libraries that might exist, where you're going to call a sanitize function on that user input, which gives you a clean HTML output. And then you use that clean output as the input to your dangerously set inner HTML. So again, I have got this HTML blob here, same as it was in the previous example. It is not rendered as a string, but it also did not throw an error. Or sorry, it also did not execute the cross-site scripting attack. So we've successfully mitigated dangerously set inner HTML, and that's all fine and good. However, that still isn't the end of the story, because there are other places where user input frequently gets used, especially when it comes to rendering that output. So 2 really clear examples in my head are things like a link, where you might take, a user profile is a really good example of this. You ask the user to put in their name, their email, their phone number, and maybe their homepage. And they'll put in http://hackingreact.io. And you'll just take that value and blindly shove it into this href. The question becomes, well, what happens if they put something like this, JavaScript : instead of the http:// JavaScript : is a valid protocol in modern browsers. And just to kind of raise this point, I can literally take that code, stick it up in my address bar, and sorry, I think I need to be on an active web page for this to work. So there we go. It'll actually execute that JavaScript for me. So what happens in this case is that if I click on my link down here, it will execute that attack. Same thing with a button, because again, we do this all the time. We'll call window.location.href, and we'll just give it whatever the user gave us. And clicking on the button will execute that code. So that's pretty dangerous. To get around that particular issue, you would again validate. You'd make sure that you have a URL class that sort of wraps the input that was given to it. At which point you can check to see if the protocol is equal to a protocol that you support. In this case, HTTP, HTTPS. And if that check passes, then give it the sanitized version of the URL. Otherwise, maybe you give it a default value, or you do something else. You don't render. So then in this case, if I were to click on that link, it'll take you to my homepage, because it didn't take my JavaScript injection. So just be careful with the different areas and the kinds of interactivity that you allow user inputs across your application. I think I've got 2 more slides here on hacking React. when we think about the different ways an attacker can get malicious input into your application, we've already talked about 3 of them. Talked about having user interaction via a keyboard. They can type in a cross-site scripting payload into an input box. Or number 2, they can edit some sort of query parameter, giving you malicious input. Or number 3, they can edit any sort of local storage or cookie values that might be able to circumvent some of the business logic that's in your application. The other 2 items we really haven't talked about would be either API responses or WebSockets. So if you're interacting with anything going across the wire to and from an API, a lot of the time, those values aren't going to be protected by the browser itself. So if a user had put in that URL example, JavaScript : and that had passed your server validation, your business logic in the app isn't really going to be prepared for that in many cases. And then finally, child windows or frames, for those of you who might be familiar with things like window.postMessage. Again, the ability for a window or a frame to send data back to the parent application. If the parent application is listening for that message being posted, you just have to be careful to validate it. And those areas of the code base, in my experience, are frequently unvalidated. So if you're curious about learning more, I did sort of have the shameless plug at the start that I'm going to be trying to turn some of this content into a course over the next 6 to 12 months. So if you'd like to learn more information or to stay on my list, please follow the link there below, and I'll be happy to keep you updated when that content becomes available. All right, so we've covered the low-hanging fruit. We've covered the React specifics. Let's assume for a moment that all of that was in vain. A hacker was still successful at exploiting something in our application. Now, obviously, the kind of attack matters here, but if we stick with the theme of cross-site scripting, we should take a step back and think about what the life cycle of an attack looks like. It's all fine and good that I'm able to execute an alert box on my React app. That doesn't really gain me much. If I'm able to get an alert box to show up on your machine, that doesn't really do me any good as an attacker. Ultimately, what I need to do is to get something from your browser back to me as the attacker so that I can do something with it. Perhaps the most clear example of this would be either a session cookie or a JWT, something that I might be able to use to authenticate myself into the application masquerading as you. If that happens, then it's kind of game over. At that point, we're on to all sorts of other deeper kinds of attacks. And we really kind of have to ask ourselves, is there something I can do about that? Or is all hope lost and you've been sitting through half an hour of me talking for absolutely no purpose? Thankfully, there is a silver bullet when it comes to cross-site scripting specifically. And that is if we can apply a content security policy to our website or application, it's going to prevent any outbound communication from your browser to the attacker. And you can do this in one of 2 ways. You can either put it on your HTTP response headers, so either the HTML file that's hosting the app or on any of the API responses. If it's on any of them, the browser will automatically then apply that policy to the application as a whole. Or you can put it into an HTML meta tag, which I believe meta tags are in the head of an HTML document. You put that on there once, and again, the entire application is secured from outbound communication. So if you don't have a content security policy in place, I would highly recommend that you get one. As a side note, as we talk about things like content security policies, as well as Chrome extensions, there is a Chrome extension to evaluate your content security policy, where it will give you really solid advice as to the strength or weakness of your policy. And this is an example here on docs.google.com. We can see that Google only wants scripts that are hosted on either the HTTP or HTTPS protocol of their own domain. Same thing with any web workers. They do allow some unsafe eval, which I'm sure is one of these that it's complaining about here. Yep. So if you're curious to learn more about content security policies, they're not always the easiest thing to set up correctly, but having a Chrome extension like this will go a long way to helping you ensure that you're only whitelisting the communications that you want, and everything else will just get flat denied by the browser. It's a really strong security posture to have. Let's see here. I do have 2 additional things to share really quickly before we dive into some Q&A. The first is something that I find really interesting. It's not necessarily something that many of you will be able to do anything about, given the way that JavaScript bundles are created. There are some ways around it, and that is being able to find any URLs that exist in an application. So if you've ever looked at a React app and you looked at the JavaScript bundle code, let's see if I can find mine. So I'm gonna click on, yeah, I think it's this one. So obviously reading compiled JavaScript that comes out of Webpack or whatever Create React app uses these days, this really kind of sucks. But if you know what to look for, maybe say like path : followed by a single or a double quote, all of a sudden, I now know what all of the React router paths are in this application. I know that XSS default exists, XSS link fix. These are all things that I did show you as I clicked through the examples here. But if you weren't sure and you were an attacker, you might come into here and say, hey, like, I wonder what all of the possible URLs are, because I can tell it's using React. Maybe I can tell it's using React Router. And this would be a really easy way to enumerate all the possible paths. Now, if you have a significantly complicated routing setup, it might not be quite as easy as what I have on the screen, but you will still be able to reverse engineer all of those routes. So take a look in your own application. I'm curious if you end up finding anything significant or at least anything interesting that you might want to protect differently given the opportunity. So that's the URLs. The second thing I wanted to show you is a tool called OWASP Zap. And again, I know we lightly touched on the OWASP top 10, which I think is really what most of us know the OWASP organization for. OWASP Zap, ZAP stands for the Z Attack Proxy. And it's kind of similar to tools like Fiddler, if any of you are familiar with that, only it's like Fiddler on steroids, where as you move through the application, the idea is that you proxy all of your network requests through OWASP Zap so it can record them. So in my case of like hacking React, it can tell all of the different routes that it ran into. And it'll tell me all of my requests and responses, similar to what Google Chrome Chrome DevTools does, similar to, like I said, Fiddler or any other number of tools. But Zap does a number of other things. I'm only going to touch on like 2 features here. The first is that if you wanted to really easily resend different requests, so in this case, I can send a request to thank you, and it'll tell me what the response is. If I wanted to come in here and change different parameters, maybe add some query values. Again, I can just really easily modify that request and see what changes in the response. So this app gets really interesting really fast when you want to do things like spidering a website, if you want to try fuzzing different URLs or APIs, where you can swap out things like your query string values for the values you may have stored in a word list on your computer. So you can do all kinds of really cool security automation. And Zap also will give you, again, some low-hanging fruit alerts, where, just as an example for hacking React.io, it's complaining that I am missing the X-frame options header, which would protect me against a certain kind of attack known as clickjacking. There might be other things, like I don't have any cross-site request forgery tokens. Now, I don't have a need for that in my application, so this might be a false positive, but this is really good information for us as developers, where maybe we didn't realize that we didn't have this header set, and that's a really easy one-line fix in your server. Or it's also just good information to realize that this is what an attacker is going to see. An attacker is going to have to figure out the false positives from the real problems, but things like suspicious comments. So in this case, it noticed there's the word user that's in a comment. Let's see here, user query. So again, these are mostly false positives here, and I can easily mark them as such. I can either delete them or mark it as a false positive. But again, really interesting information for us to know, because an attacker is going to know this just as easily. And I think that's all I got. If we've got some questions in the queue, Bill.
I see one in the chat. I don't know if you want to read it.
Let me pull up in the chat here. Let's see here. Does using a third-party identity management service offer protection against the exploits you have described? For example, Okta, and I think that's supposed to say Auth0. So third-party identity management services, so that could be like AWS Cognito, could be Okta, could be Auth0. It will mitigate some of the things that I've mentioned here tonight. So as an example, I talk about either JWTs or session cookies. You can bet a good amount of money that Okta and Auth0 and Cognito are not base 64 encoding readable values in a session cookie. They're probably doing whatever the latest and greatest encryption and hashing things exist to secure those session values or those JWT values. So the ability for them to modify them locally and have them work remotely, at least, is a problem that you don't have to worry about. Something that you might have to worry about, though, again, is how you're using those values locally when the user is looking at the app in their own browser. So if you think about the life cycle of authentication, you get back, let's say it's a JWT. A lot of applications are going to stick that JWT into local storage. And then your business logic is going to be written in a way where when the user refreshes the screen, it's going to look in local storage for the JWT, it's going to find it, it's going to use that, and then hopefully, because it's valid, it will allow the API requests to succeed. But if they've modified that JWT locally, you may have business logic that shows things on the screen that would only be there for an administrative user. So you just have to be aware of where those values are being used, how they're being used. But offloading authentication itself to a third party is typically a really strong way to handle authentication as opposed to rolling it yourself. Let's see here. Any experience with the impact of WebAssembly on threat vectors in apps? All right, so I didn't talk about WebAssembly at all today, but if I go back to, I already forget where I have my own diagram. This diagram. So WebAssembly isn't really accounted for in my diagram here. It's probably most similar to your WebSockets or your API requests. It's not exactly the same thing, but it's probably the closest thing that I can think of here. So again, as you're interacting with code that's going into and out of the WebAssembly, which is taking data and pulling it down onto the actual hardware of a machine, and then doing something with it and giving output back up to the application, you definitely should be careful with how you stick those values into the application. So if you're expecting things like URLs, make sure that they're actually URLs before you render them. Or if you're putting them into a toast notification, I have seen React applications that use toasting libraries where the toasting library is not actually in React, it's in something else. And so if that's the case, you may think you're getting all the benefits of using React in terms of rendering things as strings when in fact that third-party library might not be doing that. So nothing specifically about WebAssembly that I would say is a specific threat, but it is going to fall into these same sort of life cycle things to be aware of. Next question, are HTTP only cookies the same across browsers? Are they equally enforced? Generally speaking, yes, although I'll caveat this with I'm not actually an expert in how every browser handles cookies, but I know that the major browsers in all of their latest versions generally handle cookies the same way. So that's good, but the one problem I think that many of us who've been developers for years notice, especially if you look at your application stats in like Google Analytics, not every user is using the browsers you think they are. Often we'll get small minorities of users who are still using Internet Explorer, or they're using some really ancient version of Chrome or Firefox for whatever reason. So it is possible you have users that are experiencing cookies handled in a way that you don't typically expect, but the Chrome, Safari, Firefox, Edge really ought to all be handling cookies. The exception maybe of some bleeding edge features about the same way. Does OWASP Zap attach to your browser as an extension, or do you have to type in a web address to scan it and it scans the whole site? Okay, so OWASP Zap can do things one of two ways. Zap does have what they call its HUD, for heads up display, where you can, through the interface of OWASP Zap, pull open like a browser that's inside of Zap and start looking at an application, and you don't have to do any hooking between the browser and Zap. Or you can do what I typically do, which is to use something called Foxy Proxy. And you can then set a proxy to then, like in my case, it might be to send all network requests through my local host at port 8081, or you can change this. And Zap will automatically turn on its own proxy server. So by default, I think it's at 8081 on localhost. So you would just turn that on and then continue using Chrome or Firefox normally. And you won't notice any difference yourself, except maybe you'll have to accept the validity of a certificate, because you've got the proxy server having to host the SSL certificate in its place. So that might be the only time you really notice a difference, but otherwise it's really pretty seamless. And for what it's worth, there is there's a conference coming up called ZapCon in about a week or 2 weeks, March 8th and 9th. It's virtual. It's free. So go ahead and register for that if you like. I get no kickbacks for this, but if you want to learn more about Zap, highly recommend checking out that conference. Do we have any other questions? I think that's, oh wait, here's one that just came in. Given my concern about authentication cookies and storing JWTs and session storage, where is the best place to store it? Or is it always going to depend on the app? So here's the thing that is sort of the catch-22 of all the advice I give about web application security, is that the way that I described apps dealing with session cookies or JWTs, there's nothing inherently wrong about that approach. Putting the JWT into local storage, there's nothing wrong with that. At least nothing wrong with it in and of itself. The problem that I see is that developers typically don't think 2 or 3 steps down the line to say, well, what if somebody modified that value? 99 times out of 100, because you've got 99 valid, legitimate users, nobody's going to do that. But in the same way, where if you work for a large enough company where you've got lots and lots of QA testers, these are the kinds of exercises that they're going to do a lot of, where if you can find any possible vector to get the application to throw an error message, and having a modified and therefore invalid JWT is a great way to do that. Then that's going to potentially give away information about your web server, maybe give away a stack trace, or like I said, maybe allow a user to view a page in the application that they shouldn't have been able to view. So it's not a problem with storing the JWT like that. It's a problem with not understanding where additional validations need to be put so that an attacker can't do anything as a result of modifying that value. I hope that answered your question. Awesome. Feel free to shout out too, by the way. You don't have to be shy and type things in. Awesome. Thanks, Cliff. I appreciate that. And Justin, thank you. Well, Bill, I think that might be the end of Q&A. You got anything else